Here is your online lesson for reflections and symmetry. And again, we have vocab just like we do at the beginning of each section in this unit because we need to make sure we have an understanding of what these terms mean. So, to start off, our first word is reflection, and reflection is a transformation in which a figure is reflected or flipped in a line. A transformation in which a figure is reflected or flipped in a line. Remember, you're going to be pausing because I'm probably going to go faster than you could write it down. A line of reflection is the line in which a figure undergoes a reflection. So the line that we're flipping over, the line in which a figure undergoes a reflection. The line of symmetry, so it says a figure has a line of symmetry if a line divides the figure into two parts that are reflections of each other in the line. So that guy that actually does the cutting into the two parts is called the line, that it has line symmetry. Sorry, this one is line symmetry. That means the figure can be cut and that it's the same on each side, as opposed to the next vocab, which is line of symmetry, and that is the line that does the cutting. So a line that divides a figure into two parts that are reflections of each other in that line. Okay, so this is saying we would say something has line symmetry if it can be cut into two parts that are the same. The thing that does the cutting is the line of symmetry. All right, so we're going to look at example 1 down here. They have 3 pictures down here, and we're supposed to decide if it is a reflection, and then if it is a reflection, we say which line it's being reflected over. So basically, we have to decide if I take my arrow and I flip it over, will it match up with this one exactly? So in A, that is definitely a reflection. And it's reflected in what axis? What axis am I flipping over? So it's a reflection in the x-axis. Okay, so you're going to pause the video right now, and you're going to do B and C, and then you're going to come back and see if you were right about them. Okay, so you've done B and C now. B is not a reflection, and I hope that you were able to identify what B was. What is B? B is a slide up, right? And what's it called in a slide? It's called a translation. We've already done those. So that was a translation. It's not a reflection. And then C was flipped over that y-axis there, so it's a reflection in the y-axis. So see, Mrs. Wyman, if you have a question about one of those. Otherwise, continue on to the next page. So in these problems, we've been doing coordinate notation in this unit. And it says you can use coordinate notation to describe the images of figures after reflections in the axes of a coordinate plane. So here's a reflection in the x-axis. We're starting off at point A, and we go to point B, so we have the line segment AB. Line segment AB has been flipped over the x-axis, and now here's my new A, and here's my new B. And what's happened here is that point A was how many spaces from the x-axis? It was 3 spaces. So the new A also has to be 3 spaces. Likewise, that point A was 2 spaces from the y-axis, so now it's 2 spaces from the y-axis. Additionally, point B is 1 place from the x, so it's 1 place from the x, and it was 4 from the y, so now it's 4 from the y. The other thing you can look at is look closely at the coordinates. It's -2, 3, and now it's -2, -3. This one was 4, 1. Now it's 4, -1. So what thing changes? Does the x part of that coordinate change? No. X is still x. It was the same point as before. Did the y coordinate change? It sure did. It was positive and now it's negative. If we had started down here, it would have gone up there. So what you're doing is you're multiplying that y coordinate by -1. So we would say it's the opposite y. If I'm going to flip it over the x, the y changes. Additionally, it's the same idea here, but look closely. -4, 3 becomes 4, 3. -2, -3 becomes 2, negative 3. So this time the y is changing, but the x value is getting the reverse sign. So the x becomes the opposite of what it originally was. If it was negative, now it's positive. If it's positive, now it's negative. So that's what you have to remember when completing the following problems. So example 2 is reflecting a triangle. And again, when we're doing these problems, I told you that color is very helpful, and I would advise you to work in color now so you can see what's old and what's new. So it says to draw a triangle ABC with the vertices that are the following. So right now, go ahead and draw a triangle ABC. Okay, and then you're going to use a ruler or a really steady hand to connect these points. There's my triangle ABC. Now, what it's asking me to do is find the coordinates of the vertices of the image after a reflection in the x-axis. So that's a very specific direction there, x-axis. So which one of these two up here should we look at, the first one or the second one? X-axis, x-axis. So that tells me what? My x stays the same and my y changes its sign. X stays the same, y changes its sign. So each y coordinate we're going to multiply by negative 1 to flip that sign. So originally a was 2, 2. Now a prime becomes 2, negative 2. Remember a prime, that's the image, the new one. B is 2, 5. And you know what? I'm going to do a different color right now because I can see I'm writing in the purple, which is what I graphed the original in. And I don't want to do that, or it will be confusing. Okay, so this is going to be 2, negative 5, and 4, negative 1. Now remember, if these were originally negative, my new values would be A is 2, negative 2 now, B is 2, negative 5, and C is 4, negative 1. And then a ruler or a super steady hand to get your new one. And so 1 is literally reflected over, it's flipped over. If I took my paper and I folded it in half, those two would match up perfectly. All right, so there's a checkpoint on the next page. You are going to pause the video and complete the checkpoint. I need to see the coordinates of the new image. Find the coordinates right here. I need to see them over off to the side so I know what A prime, B prime, and C prime are. So go ahead, pause, do that, and then come back. All right, so you should have paused and done that. You do not just copy down my work or you're not going to learn anything, remember. So the blue one is my original triangle. I'm sorry, the red one is my original triangle. And these are my new coordinates over here. And they should be in blue technically. I don't have a blue at my disposal, so I'm going to make these all green here. These are all my green points over here on my coordinate plane, and notice I labeled them A prime, B prime, and C prime. And it's definitely a reflection over the y-axis. So see Mrs. Wyman if you have any questions about those. All right, so looking down below, we also want to be able to identify lines of symmetry. So we have to decide, can I cut that figure in half so that one side is identical to the other? So look at A. Is there any way to cut A so that one side would be identical to the other? Sometimes people use literally like a string of spaghetti, because see how thick my pen is? Now I'm covering up my entire figure. The other thing you can do is you can get a ruler and just use the edge of a ruler, especially those that are those clear ones, because then you can kind of see on either side. Even my ruler is a little thick. If I use this ruler right here, he's a little bit thick. But there's really no way I'm going to be able to cut this guy so that it's the same on either side and I can fold it up. So we would say there are no lines of symmetry. No lines of symmetry. In B, can you see where there's a line of symmetry? Sure. Right here down the middle. If you cut that heart in half that way, it's going to be the same on both sides, so that's one line of symmetry. There's no other way for me to cut that heart, though. Okay? And in C, how many cuts do you have there? There are actually two lines of symmetry. Did you see that there were two? You may have seen easily this one, but guess what? There's one other one, and it's right here. If I folded it that way, I would also get the same shape. Okay, so you're going to go down here, and you're going to draw on the lines of symmetry. You're going to pause the video and then come back and see how you did. I will show you that these are congruency marks. So when there's one mark on each side here, that's telling you that this measurement is the same as that measurement. But they are not the same as these two because they have two. But the two that have two are also the same. In addition, for these angles, one arc on this angle shows that one arc on this angle is the same measure. These two angles have two, so they are also the same measure. And just a reminder, when there's a box in a corner, that means that that is a 90-degree angle. Those are all 90, so you know those are also congruent, exactly the same. Okay, pause, draw in your lines, and then come back and see how you did. Okay, so in the first one, there are no lines of symmetry. There's not actually a way you can put a line of symmetry in there and have it work. Sometimes kids will draw a line here, but these two corners will not match up. Same this way, same this way, same that way. None of those corners will match up if you fold the paper. You can actually fold your paper right now if you don't believe me. In 2, there are two lines of symmetry, vertical and horizontal. They will not work diagonally again because if you folded it, the corners would not match up. And let's see how you did on number 4. There are actually 5 lines of symmetry on number 4 because each one of these points can have a line drawn through it to its opposite side. That is a hexagon. And I'm sorry, it's a pentagon, and that means that all of these angles are the same. That forces all of those sides to be the same. Penta means 5. There are 5 sides in that figure. Okay? All right. So you should be good and ready to go on to the next page in your packet. Go ahead.